Good morning, students. I am Professor Arun Wagmare. Welcome to online lecture series of a distributed computing system. Today, we will see our first unit, that is fundamentals and architectures. So, in this unit, we will cover what are the definitions of distributed systems, what are the design goals, what are the different types of distributed system, what are the characteristics, what are the advantages, what are the disadvantages, what are the different challenges for this distributed system, what are the different architecture styles for a distributed system. So we'll see one by one. In today's lecture, we'll see only what is the definition of distributed system, what are the design goals, why we build this distributed system. So first, so in introduction, we will see what are the types of computer architecture. So basically, when we consider this distributed system, so distributed system can be considered as a popular kind of a computer network and has been accepted worldwide because of its famous feature like ability to integrate a distributed applications, informations, and a resource sharing between spatial distributed end user, right, scalability, and so on. So in this this unit gives a basic introduction to distributed system, that is goals and architecture. So here, first of all, we know there are two types of computer architectures are there. First one is a tightly coupled and second one is a loosely coupled. So what do you mean by this tightly coupled architecture? So in tightly coupled architecture or tightly coupled systems, only single memory is shared by the all processor. This means all processor commonly use single memory for storage or communication between the respective processors. This tightly coupled system is also known as an equivalent processing system or a parallel processing system. What is this loosely coupled? So this loosely coupled is opposite of this tightly coupled, right? So in this kind of system, the processors do not share a memory. Here, each processor has its own memory assembled in it. So communication between number of processors takes place by using a message passing mechanism. That is, you can say by passing a message to the network. This loosely coupled system is also denoted as a distributed system, or we can say simply a scattered systems. A distributed system, we can say, is a simple language, is a group of distributed system in a simple language, we can say is a group of a processor which are interconnected by any communication network, in which each processor has its own memory, right? Each processor in the distributed system is well known as a node, site, or a machine node in a particular distributed system. So what are the different definitions of this distributed system? So definition is a distributed system is a collection of independent computers that appears to the user of the system as a single computer. Or another definition is for distributed system is distributed system is a collection of autonomous computer linked by the computer network that appear to the user of the system as a single computer. Or again another definition, distributed system in which hardware or software component located at the network computer communicates and coordinate their action only by a message passing. Right? So there are different definition of the distributed system. So why we build this distributed system? What is that? Why we need this distributed system? So there are direct, or we can say, some benefits in a building a distributed system. So what are these benefits? So first is increase the reliability. Second one is mobility. Next, computer supported cooperative networking. Then fourth one is remote services. And next, a distributed machine may make a sense. So we'll see one by one. What is this? Increase reliability. So increased reliability means what? If a small percentage of machine break down, the rest of machine remains unbroken. Right? This is we can say this increase the reliability. So what is the mobility? Mobility, that is user move around with their laptop, computers, and web phones. It is not practical or reasonable for them to carry all the information they need with them. Then the next, computer supported cooperative network. So nowadays, user that geographically separated can work together. So email is the best example for the cooperative networking. So we can say again, there is audio, video conferencing, file transfer are the some examples. So what is the remote services? Remote services, user may need to access the information held by others at their system. So example of this include the web browsing or remote file access. Then distributed machine may make sense. So it makes sense to the place CPUs or processor for the ATM cash machines at the source, each connected with the bank through the network. So each bank can have one or more computers connected with each other and with the other bank also. So next, design goals. So what are the different design goals? So there are 4 important goals should be achieved while developing this distributed system. So that is, first is resource availability, second transparency, third one is openness, and fourth is scalability. So what is this resource availability? Resource availability means what? The distributed system should make resources easily available. Resources are typically like this, there is printer, file, computers, web pages, storage facility, and so on. Right. So main goal of a distributed system is to make it easy for the end user to access remote resources and to share them in the competent and well-structured way. Second one is a transparency. This transparency also called as a clearness. So a distributed system should practically hide the fact that resources and processor are scattered across network, and hence the of automated computers. A distributed system is said to be a transparent if it is able to present itself to the end user and application as it is where only a single automated or a program computer system. So there are different types of transparencies are there. Access transparency, right? So what is this access transparency? Access transparency, that is deals with hiding the differences in data or facts representation and the method or technique with the help of which resources can be retrieved by the user. Next, location transparency. So it discusses the facts that user cannot tell where the resources is physically located in the system, or you can say it enables the information object to access without the knowledge of their location. So these are the different examples: file system, operation in NFS, pages in the web, examples, tables in the distributed database. Then migration transparency. Migration transparency. So in this type of transparency, resources can be moved from one location to another location without affecting how the resources can be accessed. Or you can say this, allow the movements of information of object within a system without affecting the operations of user or application program. So example of this, web pages. Next, concurrency transparency. This enables the several processes to operate concurrently using shared information objects without interference between them. Or we can say this transparency hides that the resources may be shared by the several competitive users. Example for this, automatic teller machine network, or we can say database management system. Next, replications transparency. So what is this replication transparency? So it deals with hiding the facts that several replicas of resources are exist. Replicas, or we can say that is the several copies of that data exist. What is the failure transparency? So in failure transparency, it hides the failure and recovery of the resources. It's nothing but the failure transparency. Then third is that it's openness. So openness is also a directness. So the distributed system should be open. An open distributed system is a system that offers the services according to standard rules and describe the syntax and semantics of those services. So what is scalability? So scalability, the distributed system should be scalable. Scalability of the system can be measured along at least 3 dimensions, that is size, can say geographical distances and administrations.